Hello everyone, welcome to Simplilearn's YouTube channel. Today we will learn machine learning projects with source code. That said, if these are the types of videos you would like to watch, then hit the like and subscribe button and the bell icon to get notified. And just a quick
Ideal way to display your machine learning skill is in the form of portfolio of data science and machine learning projects. A solid portfolio of projects will illustrate that you can utilize those machine learning skills in your profile as well. Projects like movie recommendation system, fake news detection, and many more are the best way to improve your early programming skills. You may have the knowledge, but putting it to the use what is keep you competitive. Here are 10 machine learning projects that can increase your portfolio and enable you to acquire a job as a machine learning engineer. At number 10, we have loan approval prediction system. In this machine learning project, we will analyze and make prediction about the loan approval process of any person. This is a classification problem in which we must determine whether or not the loan will be approved. A classification problem is a predictive modeling problem that predict a class label for a given example of input data. Some classification problems include spam email, cancer detection, sentiment analysis, and many more. You can check the project link from the description box below to understand classification problem and how to build a loan prediction system. At number 9, we have fake news detection system. Do you believe in everything you read in social media? Isn't it true that not all news is true? But how will you recognize fake news? ML is the answer. You will able to tell the difference between real and fake news by practicing this project of detecting fake news. This ML project for detecting fake news is concerned with the fake news and the true news. On our dataset, we create a TF-ID vectorizer with sklearn. The model is then fitted using a passive-aggressive classifier that has been initialized. Finally, the accuracy score and the confusion matrix indicate how well our model performs. The link for the project is in the description box below. At number 8, we have personality prediction system. The idea is based on determining an individual personality using machine learning techniques. A person's personality influences both his personal and professional life. Nowadays, many companies are shortlisting applicants based on their personality, which increases job efficiency because the person is working on what he is good at rather than what he is compelled to do. In our study, we attempted to combine personality prediction system using machine learning techniques such as SVD, naive-Bayes, and logistic regression to predict a person's personality and talent prediction using phrase frequency method. This model or method allows users to recognize their personality and technical abilities easily. To learn about more this project, check the link in the description box below. At number 7, we have Parkinson disease system. Parkinson disease is a progressive central nervous system element that affects movement and causes tremors and stiffness. It comprises 5 stages and affects more than 1 million worldwide each other. In this machine learning project, we will develop an SVM model using Python modules, scikit-learn, NumPy, and pandas. An SVM, we will import the data, extract the features and label and scale the features, split the dataset, design an SVM model, and calculate the model accuracy. And at the end, we will check the Parkinson disease for the individual. To learn about more this project, check the link in the description box below. At number 6, we have text-to-speech converter application. The machine learning domain of audio is undoubtedly cutting edge right now. The majority of the applications available today are the commercial. The community is building several audio-specific open source framework and algorithm. Other text-to-speech APIs are available for this project. We will utilize pyttsx3. pyttsx3 is a Python text-to-speech conversion library. It operates offline unlike other libraries and is compatible with Python 2 and Python 3. Before API, various pre-trained models were accessible in Python, but changing the voice or volume was often difficult. It also needed additional computational power. To learn more about this project, check the link in the description box below. At number 5, we have speech recognition system. Speech recognition, often known as speech to text, is the capacity of a machine or program to recognize and transfer words spoken aloud into readable text. ML speech recognition uses algorithms that model speech in terms of both language and sound to extract the more important parts of the speech, such as words, sentences, and acoustic modeling is used to identify the phonemes and the phonetics on the speech. For this project, we will utilize pyttsx3. pyttsx3 is a Python text-to-speech conversion library. It operates offline unlike other libraries and is compatible with Python 2 and Python 3. To learn more about this project, check the link in the description box below. At number 4, we have sentiment analysis. Sentiment analysis, also known as opinion mining, is a straightforward process of determining the author's feeling about a text. What was the user intention when he or she wrote something? To determine what could be personal information, we employ a variety of natural language processing and text analysis technology. We must detect, extract, and quantify such information from the text to enable classification and data manipulation. In this project, we will use the Amazon customer review dataset for the sentiment analysis. Check the link in the description box below. At number 3, we have image classification using CNN. Deep learning is a booming field currently. Most projects and problem statements use deep learning is an any sort of work. Many of you, like myself, would choose a conventional neural network as a deep learning technique for answering any computer vision problem statement. In this project, we will use CNN to develop an image processing project and learn about its capabilities and why it has become so popular. We will go over each stage of creating our CNN model and our first spectacular project. We will use the CFR10 dataset for image classification in this project. To learn more about this project, check the link in the description box below. At number 2, we have face recognition system. Currently, technology absolutely amazes people with incredible invention that makes life easier and more comfortable. Face recognition has shown to be the least intrusive and fastest form of the biometric verification over time. This project will use OpenCV and face recognition libraries to create a face detection system. OpenCV provides a real-time computer vision tool, library, and hardware. We can create amazing real-time projects using OpenCV. To learn how to create face recognition system for you, check the link in the description box below. And last but not the least, we have movie recommendation system. Almost everyone today use technology to stream movies and television shows. While figuring out what to stream next can be disheartening. Recommendations are often made based on a viewer history and preferences. This is done through a machine learning and can be a fun and the easy project for the beginners. New programmers can practice by coding in either Python or R. And with the data from the Movie Lens dataset generated by the more than 6,000 users. To learn how to create movie recommendation system for yourself or for your loved ones, check the project in the description box below.
In a world where email is crucial, spam messages plague our inboxes, disrupting our digital lives. But fear not, a hero emerges, the email spam classifier. This intelligent system learns from past encounters, uncovering the tricks employed by spammers, deceitful subject lines, promising riches, unreasonable low prices. It spots signs like excessive capital letters, misspellings, and suspicious URLs. Yet the battle doesn't end here. Spammers constantly evolve their tactics, but the email spam classifier doesn't flinch. It adapts, refining its knowledge and staying up to date with the latest tricks. Every new spam email it encounters, it provides insights, enhancing its accuracy and ensuring our protection. Thanks to dedicated minds and AI and ML power, the fight against email spam continues. The email spam classifier stands as a faithful guardian, a symbol of technology's victory over digital adversaries. It reclaims our inboxes and restores order to our virtual world. According to recent studies, AI and machine learning related job postings have increased by a staggering 344% in the past 5 years. Companies across the globe are actively seeking professionals who can harness the power of data and build intelligent systems. The average salary is $150,000 in the US and 15 lakhs per annum in India. Accelerate your career in AI and machine learning with a comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and hackathons and Ask Me Anything sessions by IBM. With 3 capstones and 25 plus industry projects using real data sets from Twitter, Uber, and more, you will gain practical experience, master classes by Purdue faculty, and IBM experts ensure top-notch education. Simplilearn's Job Assist help you notice by leading companies, live sessions on AI trends like ChatGPT, generative AI, and explainable AI. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The link is mentioned in the description box below. Let's take a minute to hear from our learners who have experienced massive success in their careers.
You need to keep updating your skills on a regular basis, no matter what level you're at. I recently completed the professional certificate program in AI and machine learning from Simplilearn in partnership with Purdue University. The course material was comprehensive and the faculty was extremely experienced. The faculty was able to adjust their teaching style in order to cater to the overall skill set of the class. In the rapidly evolving world of technology, it's important to keep upskilling for every working professional. Stay relevant, continue.
With that having said, hey everyone, welcome to Simplilearn's YouTube channel. But before we dive into that, don't forget to like, subscribe and share. And now over to our training experts.
So hello and welcome to this new video by Simplilearn email spam classifier. Okay, so first we will change this name to email spam classifier. Okay, let's rename it. So first what we gonna do we will import some libraries, then the main libraries like NumPy, Pandas, Sklearn, and logistic regression algorithm, and then we will move on to this importing of dataset of spam mail and ham mail. Ham is known as like which is not spam. Okay, so we will do some categorization of spam email and ham email. Then we will split into the training test and the testing of the data set. Okay, then we will transform the text data to feature vectors that can be used as input to the logistic regression, and then we will convert the white train and the white test values as integers. And then moving forward we will some see the features, the model extractions, and then we will train the model using logistic regression. And after that we will predict the accuracy, how much the training data is giving, how much the testing data is giving, and at the end we will build a predictive system which will tell whether a particular email is spam or not spam. Okay, cool. So let's move on to the coding part then. Okay, so first I will import some major libraries like import numpy as np. Okay, then numpy. So numpy is a powerful Python library for numerical computing. So it stands for numerical Python and provides support for efficient array operations and mathematical function, linear algebra, random number generation, and more. With NumPy, you can work with a multi-dimensional array known as ND arrays. And these arrays are highly optimized for performance and allow you to perform mathematical and logical operations on large dataset efficiently. So NumPy provides a wide range of functions and methods to manipulate and analyze these arrays. And the second one is import pandas as pd. Okay, this pd and np is nothing. We don't want to write again and again pandas and numpy. So what is pandas? So pandas is a powerful Python library used for data manipulation and analysis. It provides easy to use data structure and data analysis tool, making it essential tool for working with structured data. So the third one is scikit-learn. Okay, so I will write here from sklearn dot model selection import train test split. Okay, so what is sklearn model selection and the train test split? So sklearn or scikit-learn is a popular Python library for machine learning. It provides a wide range of tools and algorithms for various machine learning tasks, including classification, regression, and that clustering, dimensional reduction, and the model evaluation. Okay, and this train test split, this one. So the train time split function is a utility in scikit-learn that helps in splitting the dataset into training and the testing subset. Later we will split the data into training and the testing. So this function is commonly used in machine learning tasks to assess the performance of a model on unseen data. Okay, so move on to the next algorithm. We will write here from sklearn dot feature extraction dot text import tfid vectorizer. Okay, so what is tfid vectorizer? So tfid vectorizer is a feature of extraction technique commonly used in natural language processing NLP and text mining tasks. So it is a part of scikit-learn library in Python. So TFID vectorizer transform a collection of text documents into a numerical representation that machine learning algorithm can work with. Okay, so move on to, we will import from sklearn dot linear model import logistic regression. Okay, so what is logistic regression? So logistic regression is a popular classification algorithm used in machine learning. It is a part of the scikit-learn library in Python. Logistic learn and the regression is suitable for binary classification problems where the target variable has the two classes. Okay, and the last we will import accuracy score. Okay, so here I will write from sklearn.metrics import accuracy score. Okay, so let me tell you first what is accuracy score. The accuracy score function is a performance metric provided by the scikit-learn library in Python. It is commonly used to evaluate the performance of a classification model by measuring the accuracy of the predictions. Okay, so let me run it. Okay, there is some error, maybe the spelling mistake. Okay, what I will do, I will write it again. Running it again. Yeah, it's working. So now what I will do, I will import the data set. So I will write here df equals to data frame equals to pd dot read underscore csv mail underscore data dot csv. You can find this dataset link in the description box below. Okay, I will run it. Yeah, so let's see the data frame, what's in it for us. So as you can see, here is category, then message. So these are the, the mails. Ham means not spam and spam is spam. Okay, those mails which are not spam known as ham. So there are two columns, 5, 5, 7, 2 rows. So moving forward, what I will do, I will convert this mail data, okay, to not null. So I will write here data equals to raw, not raw. Data equals to df dot where pd dot not null is df. Okay, then some space. Okay, let me give you some spaces for the better visual. Yeah, so now I will print data dot head. So what is the meaning of head here? Head means if you want to print the top 5 lines of the particular data set, it is, you can use the head. And if you want to print the last 5 rows of the data set, so you can use the tail instead. If you will write here 10 instead of giving it blank, then run it. So it will give you the top 10 rows of the particular data set. Okay, so these are the spam mail, this ham mails. So later on what we will do, we will train this data set using this particular data set. Okay, so let's move on to and see the info, okay, of the data set. So data dot info. So info, you can see there are columns, this null count, this data type. So there are 2 columns like category and the message, and the particular rows are the 5572 on the both, and the data type is object. Okay, see the memory usage and you can see everything. and there is one more. You can see that it shape is 5572 comma 2. These are the rows and these are the columns, 2 columns and 5572 rows. Okay, so now what I will do, I will assign the category to spam, am and ham mail. Okay, so what I will do here, I will write here data dot loc, then data versus category equals to spam comma category, okay, comma equals to 0. So if the 0 will show, it is known as the spam, and if 1 will show, it is known as the ham mail. Okay, I will write here data dot loc location and data, then category equals to ham, then category will be 1. Okay, then let me run it. Okay, it's running smoothly. So I will write here x equals to data, then message, okay, and the y value will be equals to main, sorry, not main, data, then category. Okay, then let me run it. So now what I will do first, so now what I will do, I will write here print x. Okay, so these are only the messages, and category print y. So now as you can see 1 1 0 1 1 0. So here 0 means, what is the 0 means? 0 means spam, and the 1 means it's ham mail. Okay, so moving forward, what I will do, I will split this data set into testing and the training. Okay, so I will write here x train, this is the most important part, and the x test. Okay, then y train, then y test. Okay, equals to train test split x comma y comma test size equals to 0.2, then random, okay, random state equals to 3. Okay, I will run it. So this is x train for the training set, and x test is the testing. Okay, then the same y, you know the what is the x and y here, and here we are splitting using train test split, then x comma y test size is equal to 0.2. okay, 0.2 means it will be 80 and 20%, and 80% will be training and the testing will be 20%. Okay, we will train data, 80% of data using this data set will be trained, and for the test the 20% will data. Okay, the random state equals to 3, and the random state is a hyperparameter used to control any such randomness involved in machine learning model to get consistent result. Okay, when splitting a data set, splitting a node in a decision tree or a logistic regression, initializing centroids in clustering takes place. So that is why we use random state. Okay, so let me run it. It's working fine. So Now I will show print x dot shape. Okay, then print x underscore train dot shape. I will show you about I'm talking about the test size now. Print x underscore test dot shape. Now see carefully. Okay, this x will be in capital. So as you can see, total rows are 5572. Total row of 80% is 4457, or else you can calculate. And the 20% is for the testing is the 1115. Same goes for the y. So moving forward, okay, let me show you for the y also. So I will copy and paste it here. So let's y. See, same goes for the y also. Okay, so now what I will do here, I will transform the text data to feature vectors that can be used as input to the logistic regression. So feature extraction equals to tfid vectorizer, where the minimum difference will be 1 comma stop words stop words equals to English and the lowercase equals to true. Okay, here I am transforming the test data to the feature vector. And okay, so here x, okay, let me tell you. So this is a feature extraction. We are using tfd vectorizer. Okay, we have import here, as you can see, for the feature extraction of the text. And this is the minimum difference equal to 1. And what is the stop word? The stop words are the English words which does not add much meaning to the sentence. They can safely be ignored without sacrificing the meaning of the sentence. Okay, like for example, you can see the words like the, he, have, such words already computerized, and the captured, this is a corpus name and the corpus. Okay, and this lowercase equals to 2 true. So here I will write x train features equals to features feature extraction dot fit transform x underscore train x underscore test features equals to feature extraction dot transform to the x test. Okay, yeah. So moving forward, I will convert y train and y test values as an integer. Okay, y train, because they are 0 1 0 and 0, train equals to y train dot as type int. Okay, then y test equals to y test dot as type int. So okay, so there is spelling mistake. We'll copy from here, paste it here. Okay, then I will run it. Okay, y test it is. Yeah, it's running. So now what I will do, I will print the x train As you can see, the xtrain. So these are the messages, and if I will print xtrain features, we created here na, see xtrain features. Okay, then you can see, so these are the features accuracy. Okay, so 000 means spam, 11 means ham. Okay, so moving forward, what I will do, I will now train the model. Okay, logistic regression. So I will write here model equals to, okay, logistic regression. So now we will train the model. So here I will write model equals to logistic regression. Okay, so we don't want to write again and again logistic regression, so I am here assigning model to it. So let me run it. So here I will train the logistic regression model with the training data. So here I will write model dot fit xtrain features comma white train. Okay, here we are training the logistic regression model with the training data. Let me run it. Yeah, fine, it's running fine. So moving forward, we will do the evaluating of the train model and the prediction of the training data. So for that I will write here prediction on training data equals to model dot predict xtrain features. Okay, then I will write here accuracy on training data equals to accuracy score y train comma prediction. Okay, I will write from here prediction on the training data. Okay, let me run it. So now we will see the prediction. So I will write here prediction, or simply I will write print accuracy on training data comma. Okay, I will copy it, leave it, accuracy on training data. Okay, let me run this. So as you can see, accuracy on training data is 0.96, means almost 97%, which is not bad, very good. Okay, we will see print. Okay, now we have to do for the testing data. This is for the training data, and let's see the accuracy for the testing data. So for that I will add same prediction on test data equals to model dot predict x test features. Okay, then accuracy on test data equals to accuracy score, then y test comma prediction on test data. Okay, I'll run it. Okay, accuracy score. So here I will write print the accuracy on test data. Okay, comma, then I will write accuracy on test data. Okay, so as you can see, the accuracy on test data is almost same as the training data. Okay, almost 95%, 97%, sorry. So now what we will do, we will build a predictive system now. Okay, so I will write here like input. Okay, you have to input the mail here. Then okay, we will input later, and we will now write the line for the convert text to feature vector. So for that I will write here input data features equals to feature extraction dot transform input. Okay, this is a function, so I will write here input your main input your mail. Okay, so here we will make the prediction. Okay, I will write the prediction equals to model dot predict input data features. Okay, so I have some spam mails with myself, so I will try to copy them, and let's see. Okay, I have some mails, so I will copy it. Okay, and I will paste it here. Okay, this is the second time we have tried to contact you. You have won this. These type of mails are spam actually, like you also know. So I will try to run it. Let me run it. Okay, I forgot to write print prediction. Okay, so 0. So here, as you can see, already 0 means spam. Okay, so this is a spam mail. Actually, this is a spam mail. So okay, wait, let me write here. If prediction is showing 0 equals to true, then print it to ham mail, and else then print spam mail. Okay, the prediction will be 0, it's not equals to 1. Okay, so it will show the ham mail or else the spam mail. It's simple, pretty simple. See, 0 spam mail. Okay, I will try to put here one ham mail. Okay, let me copy it and paste it here. Okay, let me delete this quickly. Okay, let me run this. So it is showing ham mail, means not spam. So quickly let me run one more spam mail. Okay, let me copy this and paste it here. You can try with your own email with your got. Okay, so let me run this. So it is a spam mail. Okay. So here is one question for you. I will give you 1 minute for this. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. So the question is, which keyword is used for function in Python language? Option 1 Python, option 2 def, option C func, option D define. So let us know your answer in the comment section below. Okay. So I am starting off timer 1 minute. Type your answer in the comment section or in the chat section. Do let me know your answers, please. I kindly ask that everyone take part in this to make this live session exciting. So I'm starting the timer of 1 minute. Which keyword is used for function in Python language? Option 1 function, option 2 def, option C func, option D define. Which keyword is used for function in Python language? 47 seconds remaining. 30 seconds. Let us know your answer in the comment section below. This is the easy one. Which keyword is used for function in Python language? Function, def, func, or define? I kindly ask that everyone take part in this to make this exciting. 5 seconds more. Yeah. After that, allotted time has passed. Those who provided the correct response will receive a response, and those who provided the incorrect response will receive one. So now let's move to our programming part to implement loan approval prediction system. So first we will open a command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook, and here you have to select new Python 3 file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us creating a loan approval prediction system. So here I will write import numpy as np. So NumPy is a Python library used for working with arrays. It also has a function for working in domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. And the second one is port pandas as pd. Panda is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operations for manipulating numerical tables and time series. And the third one is import matplotlib.pyplot as plt. So matplotlib Python scripts can be used to create 2D graphs and plots using the matplotlib module with features to control line styles, font attributes, formatting access, and other features. It offers a module called pyplot that makes things simple for plotting. So the fourth one is import seaborn as SNS. So Seaborn, an open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the pandas library, Seaborn functioned with ease. So there is one more like from sklearn port svm. So after importing libraries, let's move forward and import dataset. So df equals to pd dot read underscore csv loan .csv. You can download this dataset from the description box below. So yeah, so dataset is imported. Let's see our dataset. So we will write df dot head here. Yeah, so here you can see we have dataset of top 5 rows. So basically head is used for showing first 5 rows of the dataset. If we will use tail instead of head, so it will show the last 5 rows of the dataset. So let's move forward and use info function to see the information about the dataset. Okay, so here we will write df.info. So the data frame information is printed via the info method. The data includes the total number of columns, their labels, data kinds, memory use, range index, and the number of cells in each column. That is non-null values. Note that the info method does indeed print the information. Okay, so here you can see loan ID is object, then this applicant income is int64, then co-applicant income is float. So non-null values like this. So we know all the column names, data types, and information. Let's move forward and see missing values in the dataset. So for that we will use, here I will write df dot is null, then braces dot sum. Yeah, is null dot sum. The dataset total number of missing values is returned via sum. Skip rows in the dataset that have missing values as a straightforward solution for the missing value data. So we have missing values in loan ID is 0, gender is 13, then loan amount is 22, self-employed is 32. So I hope you guys understand till here. If you have any questions or any query regarding any code, so just put as in comments. Our team will shortly provide you the correct solution. I'm repeating again. I hope you guys understand till here. If you have any questions or any query regarding any code or any question related to Python, just put as in comments. Our team will shortly provide you the correct solution. Moving forward, we will create one more column, that is loan amount log, using loan amount detail, and then we will display a histogram for that. Okay, so let me do first, for the better view I can do this. Yeah, I will write here df loan amount underscore log, yeah, equals to np dot log df. Now we will do df loan amount underscore log dot hist for the histogram, then bins I will take 20. NumPy.log, a mathematical function that helps user to calculate natural logarithms of x where x belongs to all the input array elements. You can see histograms. It's looking fine. Let's see the null values in our new column. So I will write here df dot is null dot sum. So here you can see in loan amount log there are 22 missing values. So moving forward, let's create one more column named total income. In this, we will add two columns, applicant income and co-applicant income. And we will display histogram for the same. EF, like total income, equals to DF applicant income. And we will add one more data frame DF, that is co-applicant F total income underscore log equals to np dot log df total total df total income underscore log dot hist ins equals to 20. Yeah. So here you can see histogram of the total income log. Moving forward, let's fill those null values in all the respective columns. So here for that we will write df gender dot fill na df gender dot mode 0 comma in place equals to true. And what I will do, I will copy from here, change here gender to married, here also married, and here for self employed, here I will do self employed to for dependent, just everything will be same. So here I will write df dot loan amount was to df dot loan amount dot fill na df dot loan amount dot mean. So here I will write, instead of this I will copy from here and paste it here. Yeah, score log L is small. So here I will write again that we can take it from here. Change column name to loan amount term loan amount term credit underscore history gain credit underscore history. So here I will write df dot is null sum. Okay, it's what giving error. Sam self-employed. Okay, what the issue is that E is capital. Again, dependent. Okay, okay, it's dependence. Okay, yeah. So there is no missing values now. What we're gonna do is we will select some specific columns and rows for the training and testing. So for that, I will write here x equals to dot ilog dot r in colon 11 comma 13 colon 15. Okay. Dot values y equals to df dot ilog then colon comma 12 dot values. Let me see the x values. Okay, so male, no, these are the x values, and let me see the y values. Okay, so the ilog function in Python is defined in the pandas module that helps us to select a specific row or column from the dataset. Using the ilog method in Python, we can easily retrieve any particular value from a row or column by using index values. So moving forward, let's see the percentage of missing genders from the dataset, and we will do it for many other columns. Okay, so if it will be 0, so it will be great for us. So we will write print percent of missing gender is percent to f percent. And we will write this df in gender column dot is null dot sum df dot shape 0 multiply by 100. It is saying function object has no attribute sum. Okay, why? Because here percent of missing gender is 0. Great. So so moving forward, we will see number of people who take loan as a group by gender. Okay, so for that we will write print numbers of people who take loan as group by gender. For that, print df gender dot value value counts sns dot count plot x equals to gender comma data equals to df palette equals to set1. You can use either set2 or either set3. So let me see. Okay. So here you can see like male is 502, female are 112. You can see the bar plot. So the number of observation in each category bins are displayed using bars. Using the count plot technique, the following parameters are accepted by the procedure and are listed below. This parameter accepts optional variable names for data or vector data, inputs for long form data plotting. So moving forward, we will do for the same like number of people who take a loan group by marital status. So what I will do, I will just copy from here and I will change it to here. So I will write marital status and the guys who are married. Here I have to write the married. So here you can see like 401 are yes, like and 213 are no. Okay. So moving forward, we will see number of people who take loan group by dependents. So same what I will do, I will paste it here. I will just change the name here. Dependents. Change it to here. So here you can see the dependents and the Y label is the count. So like 0 are 360, 102, 101 and 51 and many more. So moving forward, we will see number of people who take loan group as a self-employed. Okay. For that, what we have to do is we have to just change the names. E is capital here. Okay, let's see the graph. So moving forward, we will see number of people who take loan group by loan amount. For that, I have to write here. Wait, let me make a better visibility. Yeah. So as a loan amount is capital. Yeah. Here you can see bar graph. So at the end, we will see the number of people who take loan group by credit history. Okay. So I will write here same as the credit history, credit history, free, credit underscore history. Okay. Yeah. So here you can see 525 and this 89. So based on my assessment, we don't have any missing values in the dataset now. So moving forward, let's import scikit-learn library for training and testing dataset. So here I will write from sklearn.model model underscore selection port train underscore test underscore split. So I have like train comma x test comma y train comma y test. Okay. So here I will write train underscore test underscore split x comma y comma test underscore size equals to 0.2 random state equals to 0 from sklearn dot pre processing import label encoder. Okay, so label score x equals to label encoder. Sklearn, sorry, my bad. X is not defined. Here we have so scikit-learn or sklearn is the one of the most robust library for machine learning. It is open source and built upon NumPy, SciPy, and Matplotlib. It provides a range of tools of machine learning and statistical modeling. And train test split function of the sklearn model. Selection package in Python splits arrays or matrices into random subsets for train and test data. And label encoder encode label with a value between 0 and n classes minus 1, where n is the number of distinct label. Moving forward, let's fit and transfer data for training. So here we will write for I in range 0 comma 5 x underscore train comma I equals to label encoder underscore x dot fit transform and x underscore train colon comma I. And x underscore train 7 equals to encoder underscore x dot fit transform underscore train 7. Let's see x underscore, oh sorry, underscore train, and yeah, this I. This is capital X. Fit transform joins these two steps and is used for the initial fitting of the parameter on the training set, while also returning the transformed X. Internally, the transfer object just calls first fit and then transform on the same data. And we will perform same for the Y. So I will write here label encoder underscore Y. So label encoder. Okay. Y underscore train equals to label encoder underscore Y dot fit underscore transform we see the results. Yeah. So training of the data set is done. Let's do for same for the testing data. So I will write here for I in range 0 comma 5 underscore test I equals to label coder underscore x dot fit underscore transform underscore test of I. Then again x underscore test colon comma 7 equals to label encoder underscore dot fit underscore transform underscore test, then colon comma 7. Yeah, then see the results x underscore test. Okay, it seems good, all the values. So we will do for the same y test. So we will write here label encoder. Let me put underscore y equals to label encoder. So y underscore test equals to encoder underscore y dot fit underscore transform y underscore test. Let's see. Okay. Moving forward, we will import standard scalar for the further process. So for that, we will write here from sklearn dot pre-processing import standard scalar. This is equals to, like, we'll assign this standard. I will copy it from here. So x train equals to ss dot fit underscore transform x underscore train. Then x underscore test equals to ss dot fit underscore transform x underscore test. Well, okay, sklearn dot pre-processing. Okay, sklearn pre-processing standard scalar. Okay, sorry. And again, like standard. Okay, er. Yeah. So standard scalar removes the mean and scales each feature variable to unit variance. This operation is performed feature-wise in an independent way. Everything is done. Let's see which classifier is best for prediction by seeing their accuracy. So for that, I will write here. Let me do one thing. Yeah. So like I will write from learn dot ensemble. Yeah. Import random forest classifier. So I will write IF under class CLF classifier equals to random forest. Sorry, my bad. So RF underscore CLF dot fit X underscore train comma Y underscore train fine. So I will write here from sklearn import matrix Y underscore prediction equals to RF underscore classifier dot predict X underscore test. So here I will print accuracy of random random forest classifier is comma matrix dot accuracy score then y underscore prediction comma y underscore test y underscore prediction. So let's see the prediction from the using a random forest classifier and the accuracy. A random forest is a meta estimator that employs averaging to increase predicted accuracy and reduce overfitting. If bootstrap equals to true, the size of the subsample is determined by the max sample argument. Otherwise, each tree is constructed using the entire dataset. So here you can see the accuracy is like 78%, and here prediction you can see like here 1 denotes that loan approved and 0 means loan will not approved. So accuracy is quite less. So let's see for another classification methods naive bayes. So here I will write from sklearn import Gaussian NB naive Bayes. Okay, so NB classifier equals to Gaussian NB B underscore classifier equals to dot fit strain comma y train. So a not equals to like Gaussian. Okay, G is capital. Sorry. Yeah. So let's predict the value y underscore predict equals to NB underscore classifier dot predict x underscore test and print accuracy of naive Bayes is comma like matrix dot accuracy score y underscore prediction comma y underscore test. So accuracy of Gaussian NB is 0.8 means 82%. Let's predict the value. Y predict the prediction like 1 is like loan approved and 0 is loan or not approved. So naive Bayes is a classification algorithm for binary two classes and multi-classes classification problem. It is called naive Bayes. The calculation of the probabilities for each class are simplified to make their calculation tractable. So the accuracy is 82%. And here prediction you can see 1 denotes loan approved and 0 means loan will not approved. So let's see for another classification method like decision tree classifier. For that, I will write here from sklearn dot tree import decision tree classifier. Here I will write dt underscore classifier equals to, I will copy it from here. I will write here dt underscore clf equals to, no, so dot fit x underscore train comma y underscore train y is small. So here I will see the accuracy equals to dt underscore classifier dot predict x underscore test. So here I will print accuracy of decision tree is comma matrix dot accuracy underscore predict comma y underscore test. So here you can see the accuracy is 70%. So let me predict. So decision tree, the non-parametric supervised learning approach used for classification and regression application. It is organized hierarchically as and has a node root, branches, internal nodes, and leaf nodes. So the accuracy is 70%, and here prediction you can see 1 denotes the loan approved and 0 means loan will not approve. So let's do one more classification. We will do it from the k neighbors using k neighbors. So here we will write from klearn dot neighbors import k neighbors classifier kn classifier. We will assign this. So here we will write kn underscore classifier dot fit x underscore train comma y underscore train. Okay, sklearn. Sorry. Then again, okay, it's capital here, capital here. Yeah, it. Yeah. So here I will see the accuracy. Okay. By prediction equals to kn underscore classifier dot predict x underscore test print accuracy of k neighbors is matrix dot accuracy score y underscore prediction comma y underscore test. So let's see the accuracy. So accuracy is 79% and it is quite good. So the k neighbors, the 5 closest neighbors are sought for the k neighbors classifier. The classifier must be explicitly instructed to utilize Euclidean distance to determine the proximity of nearby points. So the accuracy is 79%. And here prediction you can see 1 denotes the loan approved and 0 means loan will not approve. So you can see naive base. Where's naive base? Yeah. So here you can see we have naive based classifier with the best accuracy of 82%. So we can use it for the loan approval prediction system. So I hope you guys understand till here. If you have any questions or any query regarding any code, just put as in comments. Our team will shortly provide you the correct solution. I hope you guys must have understood the concept of how we can implement loan approval prediction system using Python. If you have any queries, you can ask in the comment section below. Our team will shortly respond to you as soon as possible. And if you want this full code, just comment for the same. Thank you so much for being here. If you enjoyed this video, please do subscribe to our YouTube channel and give a like to this video. What is fake news? False or misleading information that is reported as news is called fake news. A common goal of fake news is to harm someone or something reputation or to profit through advertising. The term fake news was first used in 1890s, a time when dramatic newspaper reports were common. even though incorrect information has always been disseminated throughout history. However, the phrase has no clear definition and is often used to refer to all misleading information. High profile individuals have also used it to refer to any news that is not favorable to them. So, dear learners, if you want to upskill your AI and machine learning skill, so give yourself a chance to Simply Learn Professional Certificate Program in AI and Machine Learning, which comes with a completion certificate and in-depth knowledge of AI and machine learning. Check this course details from the description box below. Now let's move to our programming part. So first we will open a command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Center. And here I have to select new Python kernel file. Okay. So this is how the kernel look like. So first we will import some major libraries of Python. So here I will write import pandas as pd and import numpy as np. Then import cborn as sns. Okay. Then import sklearn dot model selection import train underscore test underscore split. Before that, I will import matplotlib dot pyplot as plt. Okay, then I will write here from sklearn dot matrix import accuracy score. Then from sklearn dot matrix import classification to report and import re, then import string. Okay, then press enter. So it is saying, okay, here I have to write from everything seems good. Loading. Let's see. Okay, till then, NumPy is a Python library used for working with arrays. It also has function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. Pandas. So Panda is a software library written for Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. Then, Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the Pandas library, Seaborn functions with ease. Then, Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform for the data visualization and graphical charting package. As a result, it presents a strong open source suitable for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Then this train test split. We may build our training data and the test data with the aid of sklearn train test split function. This is so because the original dataset often serves as both the training data and the test data. Starting with a single dataset, we divide it into two datasets to obtain the information needed to create a model, like Hone and test. Accuracy score. The accuracy score is used to gauge the model's effectiveness by calculating the ratio of total true positive to total true negative across all the model prediction. This RE, regular expression. The functions in the model allow you to determine whether a given text fits a given regular expression or not, which is known as RE. Okay, then string. A collection of letters, words, or other characters is called a string. It is one of the basic data structure that serves as the foundation of manipulating data. The str class is a built-in string class in Python. Because Python strings are immutable, they cannot be modified after they have been formed. Okay, so now let's import the dataset. We will be going to import two datasets, one for the fake news and one for the true news, or you can say not fake news. Okay, so I will write here pf underscore fake equals to pd dot read underscore csv, or what can I say, df fake. Okay, data underscore fake. Okay, then fake dot csv. You can download this dataset from the description box below. Then data dot true equals to pd dot read underscore csv. Sorry, csv. Then fake news. Sorry, true. True dot csv. Okay. Then press enter. So these are the two datasets. You can download these datasets from the description box below. So let's see the board dataset. Okay. Then I will write here data underscore fake dot head. So this is the fake data. Okay. Then data underscore true dot head. And this is the true data. Okay. This is not fake. So if you want to see your top 5 rows of the particular dataset, you can use head. And if you want to see the last 5 rows of the dataset, you can use tail instead of head. Okay. So let me give some space for the better visual. So now we will insert column class as a target feature. Okay. Then I will write here data underscore fake class equals to 0. Then data underscore true and class equals to 1. Okay. Then I will write here data underscore fake dot shape and data underscore true dot shape. Okay, then press enter. So the shape method returns the shape of an array. The shape is a tuple of integers. These numbers represent the length of the corresponding array dimension. In other words, a tuple containing the quantities of entries on each axis is an array shape dimension. So what's the meaning of shape? In the fake world, in this dataset, we have 2, 3, 4, 8, 1 rows and 5 columns. And in this dataset, true, we have 2, 1, 4, 1, 7 rows and 5 columns. Okay, so these are the rows, column for the particular dataset. So now let's move and let's remove the last 10 rows for the manual testing. Okay, then I will write here data underscore fake underscore manual testing was to data underscore fake dot tail. For the last 10 rows, I have to write here 10. Okay, so for I in range 23481 sorry 0 comma 23470 comma -1. Okay. Then df underscore not df data underscore fake dot drop 1. Yeah. Instead of 1 I can write here I comma axis equals to 0 in place equals to true. Then data not here data underscore same I will copy from here and I will paste it here and I will make the particular changes. So here I can write true, here I can write true. Okay. Then I have to change a number 21416. Write 21406 -1 same. So press enter. X is equals to 0. Let syntax. Maybe you mean 00 or show of this. Okay, we will put here double equals. And I'm putting this fake dot drop I x is to 0. Okay, in place. Okay. Here also write equals to and equals to. Yeah. So okay, axis is not defined. Now it's working. So let me see now data underscore fake dot shape. Okay, and data dot true and data underscore true dot shape. As you can see, 10 rows are deleted from each dataset. Yeah. So I will write here data underscore fake underscore manual testing and class equals to 0 and data underscore true underscore manual underscore testing class equals to 1. Okay. Just ignore this warning. And let's see data underscore fake underscore manual testing dot head. As you can see, we have this, and then data dot sorry underscore true underscore manual testing dot head time. Okay. This is the true data set. So here I will merge data underscore merge equals to pd dot concat. Concat is used for the concatenation. Data underscore fake data underscore true, comma axis equals to 0. Then data underscore merge dot head the top 10 rows. Yeah, as you can see, the data is merged here. Okay. First it will come for the fake news and then with the for the true news. And let's merge true and fake data frames. Okay, we did this, and let's merge the column. Then data dot merge dot columns, or let's see the columns. It is not defined, but I did data underscore merge. These are the columns name, title, text, subject, date, class. Okay, now let's remove those columns which are not required for the further process. So here I will write data underscore or equals to data underscore merge crop title we don't need, then subject we don't need, then so one. So let's check some null values. It's giving error where because of this. That's good. Then data dot is null dot sum center. So no null values. Okay. Then let's do the random shuffling of the data frames. Okay. For that, we have to write here data equals to data dot sample one. Then data, okay, data dot head. Okay. Now you can see here the random shuffling is done, and one for the true data set and 0 for the fake news one. Okay. Then let me write here data dot reset underscore index place equals to true. Data dot drop comma axis equals to 1, then comma in place equals to true. Okay. Then let me see columns now. Data dot columns. So here we have two columns only. Rest we have deleted. Okay. So let me see data dot add. Yeah, everything seems good. Let's proceed further and let's create a function to process the text. Okay. For that, I will write here what. Okay. You can use any name text and text equals to text dot lower. Okay. And text equals to re dot for the substring. Remove these things uh, from the datas. Okay. So for that, I'm writing here comma. Okay. Then text equals to re dot substring comma comma text. Okay. Then I have to write text equals to re dot substring www dot s plus comma comma text. Okay, then text equals to re dot substring, then dot comma. Okay, then text equals to re dot substring, then percentage as again percentage for re dot escape function. Right here string dot punctuation. Okay, comma then text, right? Then text equals to re dot substring and n comma text equals to re dot substring right here, and again d, then again. Okay, then comma then again text here. Okay, then at the end I have to write here return text. So everything like this these type of special character will be removed from the data set. Okay, let's run this. Let's see. Yeah, so here I will write df, sorry, not df, data, then text pursue data, okay, dot apply to the function name what opt. Okay, then press enter. Yeah, so now let's define the dependent and independent variables. Okay, x equals to data text and y equals to data class. Okay, then splitting training and testing data. Okay, sorry. So here I will write x underscore train comma x underscore test, then y underscore train comma y underscore test equals to train underscore test underscore split, then x comma y comma test underscore size equals to 0.25. Okay, press enter. So now let's convert text to vectors. For that I have to write here let me z it's x. So here I will write from sklearn dot feature extraction dot text import t vectorizer. Okay, then vectorization equals to t fid vectorizer. Okay, then xv underscore train equals to vectorization or tion vectorization dot fit, then transform x underscore train. Okay, then xv underscore test equals to vectorization dot transform x underscore test. Okay, then press enter. Uh, so now let's see our first model, logistic regression. So here I will write from sklearn dot linear underscore model. Okay, import logistic regression. Okay, then lr equals to logistic regression, and I have to write here lr dot fit, then xv dot not dot xv dot train comma xv underscore test. Okay, press enter. xv.train. Okay, here I have to write y train. Okay, then press enter. Will work. So here I will write prediction underscore linear regression equals to lr dot predict xv underscore test. Okay, let's see the accuracy score. For that I have to write lr dot score, then xv underscore test comma y underscore test. Okay, let's see the accuracy. So here as you can see accuracy is quite good, 98%. Okay, now let's print the classification port y underscore test comma prediction of linear regression. Okay, so this is, you can see precision score, then f1 score, then support value accuracy. Okay, so now we will do this same for the decision tree gradient boosting classifier, random forest classifier. Okay, then we will do model testing, then we will predict the score. Okay, so now for the decision tree classification. So for that I have to import from sklearn dot tree import decision tree classifier. Okay, then at the short form I will write here, I will copy it from here, then okay, then I have to write the same as this, so I will copy it from here and here. Just change linear regression to decision tree classifier. Okay, then I will write here same, so dt equals to dt dot predict xv underscore test. It's v still loading, it will take time. Okay, till then let me write here for the accuracy dt dot score v underscore test comma y. Okay, let's wait. Okay, let's run the accuracy. So as you can see accuracy is good than this linear regression. Okay, logistic regression. Okay, so let me show you the, let me predict print the- so this is the accuracy score, this is the all the report. Yeah, so now let's move for the gradient boosting classifier. Okay, for that I write from sklearn dot ensemble port gradient boosting classifier. classifier. I will write here GB equals to, let me copy it from here. Okay, I will give here random underscore state equals to 0. Wait. So I will write here GB dot fit xv underscore train comma y underscore train. Okay, then press enter. So here I will write predict underscore GB equals to GB dot fit, sorry, predict xv dot test, not dot underscore test. Till then it's loading, so I will write here for the score, then I will add GB dot score, then xv underscore test comma y underscore test. Okay, so let's wait, it is running this part. Till then let me write for the printing this. Okay, it's taking time, still taking time. What if I will run this? It's not coming because of this. Yeah, it's done now, so you can see the accuracy is uh, not good than decision tree, but yeah, it is also good, 99.4 something. Okay, so now let's check for the last one, random forest. First I will do, for the random forest we have to write from sklearn dot ensemble import random forest classifier. Okay, then here I will write rf equals to, right, I will copy it from here, then random state equals to 0, then rf dot fit v underscore train comma y underscore train. Okay, then press enter and predict underscore rc or f equals to rf dot predict v underscore test. Okay, till then I will write here, it's still loading, it will take time. So till then I will write for the score accuracy score xv underscore test comma y underscore test. Okay, then I will write here till then print classification port and y underscore test comma, it will take time little bit, so it run, the accuracy score is 99, it is also good. So now I will write the code for the model testing. So I will get back to you but after writing the code. So I have made two functions, one for the output label and one for the manual testing. Okay. So it will predict the all the from the all models from the repeat. So it will predict the news is fake or not from all the models. Okay. So for that, let me write here news was to string put. Okay. Then I will write here manual underscore testing. Okay. So here I will you can add any news from the you can copy it from the internet or whatever from wherever you want. So I'm just copying from the internet, okay, from the Google, the news which is not fake. Okay, I'm adding which is not fake because I already know I searched on Google. So I'm entering this. So just run it. Let's see what is showing. Okay, string input object is not callable. Okay, let me check this first. Okay, I have to give here str only. Yeah, let's check. Okay, I have to add here again the script. Yeah, manual testing is not defined. Let me see manual testing. Okay, I have to edit something. It is just GB and it is just RF. Still GBC is not defined. Okay, okay. So what I have to do? I have to remove this. Okay, everything seems sorted now. Yeah. So as I said to you, I just copied this news from the internet. I already know the news is not fake. So it is showing not a fake news. Okay. So now what I will do, I will copy one fake news from the internet and let's see it is detecting it or not. Okay. So let me run this and let me add the news for this. So all the models are predicting right it is a fake news, or you can add your own script like this is the fake news. Okay, I hope you guys understand till here. So I hope you guys must have understand how to detect a fake news using machine learning. You can copy any news from the internet and you can check it is fake or not. Okay, or if your model is predicting right or not. So if you have any queries, you can ask in the comment section below. Our team will respond you as soon as possible. Okay. Don't forget to check the course link from the description box below. And you can download this dataset from the description box below. And if you want this full code, full code, just comment for the same. What is image classification? The process of classifying an entire image is known as image classification. Images are anticipated to have just one class per image. Models for image classification taken an image as input and produce a prediction of the class to which the image belongs. So we can utilize image classification models when we are not interested in individual instance of items with position information or their shape. So let's see what is CNN. Machine learning includes convolutional neural networks, also known as convents or CNNs. It is a subset of the several artificial neural network models that are employed for diverse purpose and datasets. A CNN is a particular type of network design for deep learning algorithm that is utilized for tasks like image recognition and pixel data processing and so more. Okay. Although there are different kinds of neural network in deep learning, CNNs are preferred neural architect for identifying and recognizing objects. Therefore, they are really suited for computer vision activities and applications where accurate object recognition is crucial, such as facial and self-driving automobile system. So moving ahead, so dear learners, if you want to upskill your AI and machine learning skills, so give yourself a chance to simply learn professional certificate program in AI and machine learning, which comes with the completion certificate and in-depth knowledge of AI and machine learning. Check this course out details from the description box below. So now let's move to our programming part of how to do image classification using CNN.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So first we will open a command prompt to write a command to open Jupyter Notebook. So here we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook. So here you can select new Python file. So this is how the kernels look like. Okay, Jupyter Notebook kernels look like. So first we will import some major libraries of Python, which will help us in like analyzing the data. Okay. So in this file, we will classify small images of CIFAR 10 dataset from TensorFlow Keras dataset. There are total 10 classes as shown below. So we will use CNN for the classification purpose. Okay. So here I will write import TensorFlow as TF. Okay. So from TensorFlow dot Keras import datasets comma layers models. Okay. So we will import numpy as np, right? And import matplotlib as plt, right? Okay, so here I will write pyplot as plt, right? So TensorFlow, this one, this. So TensorFlow is a free and open source machine learning and artificial intelligence software library. It can be used for a variety of applications, but it focuses on mainly deep neural network training and the inference purpose. Okay, got it? And this NumPy. NumPy is a Python library used for working with arrays. It also has a function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. And this third one, Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for MATLAB. The APIs, application programming interfaces for Matplotlib allow programmers to incorporate graphs into GUI applications. Got it? So let's run this. Let me change image classification using CNN. Okay. So let's load the dataset. Okay, we will load the dataset from the load data function. So here I will write x underscore train comma y underscore train. Okay, and one for test x underscore test comma y underscore test. Okay, then equals to data sets dot we are using cipher 10 cipher 10 far 10 dot load dot underscore data. Okay, so it will load our data. So let's load the data. So data is loaded. Let's see x underscore test dot shape. Okay, yeah. So as you can see, so we have 1,000 rows and one more x underscore train dot shape. Let me run this. So here you can see, like we see like training data, like training images are 50,000 and the test images are 10,000. Okay, so this is for testing, this is for training. And so moving ahead, we will see for the y train dot shape. Okay, 1000, and here we will see the array. So y underscore train no, 5. Okay, let's run this first. Let me give some space. Yeah. So here y underscore train is a 2D array. Like for our classification, having 1D array is a good enough. So what we will do, we will convert this to now 1D array. This is 2D array. We will convert into 1D array. Okay. For that, we'll write here y underscore train equals to y underscore train dot reshape -1 comma. Okay. Then y underscore train and again semicolon 5. Let's run this. Okay, so now this is 1D array. So y underscore test equals to y underscore test dot reshape in -1. Here I will write classes equals to, there are some classes, okay, in the data set, like airplane, comma, automobile, comma, bird, comma, cat, comma, deer, comma, dog, and frog, horse, ship, the truck. Okay, so these are the some classes like airplane, automobile, bird, cat, deer. So it will be help in classifying the images. So let's plot some images to see like what they exactly are. Okay. So what we will do, we will create one function for that. Let me write here def plot underscore sample. Okay. Then x comma y comma index. Okay. Then I will write here plot dot figure, plt dot figure. Then figure size should be comma 2 equals to plt dot show, image show to I am show x index plt dot x label classes y index. Okay, so let's see some samples of the images. So I will write a plot underscore sample x underscore train comma y underscore train. Okay, comma, let's see the fifth image. Okay, then enter. Should be capital. So as you can see, this is a car, so it is showing automobile. Okay, so let's see once more, like plot underscore sample x underscore train comma y underscore test comma, we'll see the 10th one. Okay, it is not quite visible, so we'll go for the 11. Okay, okay, I am why it is showing wrong, because I use here test. I have to use here train instead of test. Then it will show, I think, correct. Yeah, you can see horse, then horse. Then what about 201 image? See, you can see. So we will see once more. 500. You can see frog. Okay, it's not quite visible. Yeah. So you can see here the proper shape. Okay. So what we will do now, we will normalize the images to a number from 0 to 1. Image has 3 channels like RGB colors. So, and each value in the channel can range from 0 to 255. Hence, to normalize in 0 to 1 range, we need to divide it by 255. Okay. So now what we will do, we will normalize the data. So here, what we will do at x underscore train equals to x underscore train divided by 255.0. Okay. And same for test equals to x underscore test divided by 255.0. Okay, to range between 0 to 1. Yeah, we will build simple artificial neural network for image classification first. Okay, so we will write here ANN equals to models dot sequential. Okay, then I will write here layers dot flatten input underscore shape equals to 32 comma 32 comma 3. Okay, then again layers dot dense 3000 comma activation equals to ReLU. Got it? Then again for the 1000, so I will, what I will do, I will copy it and paste it here. Okay, so 1000. So let me add one more layer dot dense, then we'll add 10 comma activation equals to softmax. Okay, here I will. Okay, let me give for the better visuals. Yeah, so ann dot compile optimizer, okay, equals to sgd, then comma, I will write here loss equals to sparse categorical cross entropy. Okay, so here I will write comma, then matrix equals to accuracy, and ann dot fit underscore train comma y underscore train comma epochs. Okay, so number I will give epochs equals to 5, right? So it will take time to run. It's running. Here there is some issue. Underscore train epochs equals to 5. What it is saying, end user code, the file program C engine. Okay, so I will copy it and paste it again. Run it again. Okay, now it's working. Okay, so it will take time and then I will get back to you. Okay, then import numpy. You guys already know what numpy is. Np y underscore prediction equals to ann dot predict x underscore test. Okay, then y underscore prediction underscore classes equals to np dot argument max element for element in y underscore prediction. Print classification port comma classification underscore report, then y underscore test comma y underscore prediction underscore classes. Okay, so let me run this. This is capital. Yeah, it will take less time. Now we will create a graph. Okay, like X text is like we have 1,000 images, so graph will be like messed up. Still, let's see. So I write here import Cborn as SNS. Okay, okay, Cborn. Yeah, let me give some space. Here I will write plt dot figure because size should be 14,7. Okay, then SNS we will create a heat map for this. Then y underscore prediction not equals to true. Then plt dot y label is truth. Okay. Plt dot x label prediction. Then plt dot title should be fusion. Okay, then plt dot show. Let me run this. Okay. See, y prediction has x text. It's still running. Let's wait. So now let's make CNN model, okay, to train our images. So for that, I will write CNN equals to models dot sequential. Okay, right here, go paste here. Yeah. So let me run this. So this is our CNN model from which we will train our images, and CNN like compile, then optimizer equals to Adam. Okay. Okay, comma right here. Then loss equals to sparse categorical. Okay, then cross entropy. Okay, and comma. I will write here matrix equals to accuracy. Run this. Okay, loss. Yeah, same goes for you. Okay, loss. What will I do? I will rewrite this. Okay, now let's check CNN model for the 10 epochs. Okay, let's see the accuracy is increasing or not. CNN dot. Let's go train. comma y underscore train, comma box equals to it is started. It will take less time than the previous one. Okay, see, you want this whole code, you can comment down the same. Okay, so after completing this, I will get back to you. So it is almost done, like 27 seconds with 10 epochs. Till then, let me write cnn dot evaluate x underscore test, comma y underscore test. Okay. So with CNN, the end 5 epoch accuracy was around like 70%, and which is a significant improvement over ANN. Okay, ANN we have like just 49. Okay, and CNNs are the best for image classification and gives the superb accuracy. Also, computation is the much less compared to simple ANN, as max pooling reduces the image dimension while still preserving these features. Okay, so let me run this. It'll take some time. Till then, I will write y underscore prediction equals to CNN dot predict, and x underscore test. Okay. Then I will write a y underscore prediction, then colon 5. Let me run this. So you can see the accuracy and all, the array. Okay. Yeah. So let's classes equals to np dot arg max element for element in y prediction. Okay. Then y underscore classes, then these are the number of classes, then y underscore test is column 5. These are the array, so it's converted into array. Then now let's see the it is predicting right image or wrong image. Okay, by not with the training data. Here we predict from the training data, y training, x train. Okay, now we will predict from the test data. So here I will write plot underscore sample, then x underscore test, comma y underscore test, and you can write the random one. So here I will write 60. Let's see. So you can easily see here this is horse and it is predicting right horse. And let me, okay, plot underscore sample, then x underscore test, comma y underscore test, comma 100. Okay, press enter. Okay, x is capital. Yeah, so you can see this is deer. Okay, so our model is predicting the correct image. Okay, then what we like, let's see it is predicting the right class or not. Okay, we made the classes like random classes. Okay, where are these? So let's see it is predicting right or wrong. Okay, for that I have to write classes y underscore classes. It's like which number? 60. Okay, 60. Okay, 60 is not defined because like number of classes. Okay, okay. So there are 1, 2, 3, 4, 5, 6, 7. Okay, 0 to 9. I can choose. So here what I will do, I will take the small one. Like I will 5. Okay, this is frog. Okay, this frog, right? So I will take instead of 60 here I will see frog. Okay, y class is not defined. Y underscore classes. Is defined. See, okay, there are 3s. Yeah. So as you can see, frog. This is frog. So our class is defining right. So here I will write it again like 60. It was horse. And let me write here 60. You can see the right prediction. Okay. So this is what how you can do image classification using CNN. I hope you guys must have understood this concept, like how to do image classification using CNN. You can ask in the comment section below if you have any queries regarding code or Python machine learning or any course related query. So our team will respond to you as soon as possible. Don't forget to check the course link from the description box below. And if you want this full code, you can just comment for the same.
So what really is stock market? A stock market is a place or a public market where you can buy and sell shares for publicly listed companies. The stocks, which are also known as equities, represent ownership in the company. The stock exchange is the mediator that allows the buying and selling of shares. Amsterdam Stock Exchange is the oldest stock exchange that were established in 1602. The top stock exchanges in the United States are the New York Stock Exchange, NASDAQ, American Stock Exchange, and Chicago Board Operations Exchange. In India, we have the Bombay Stock Exchange or the BSE that was established in 1875 and it's Asia's first stock exchange. We also have the National Stock Exchange or NSE. Now, let's understand the importance of stock market. Stock markets help companies to raise capital. If stock markets did not exist, then companies would have to resort to borrowing loans from the banks to raise money for expansion. This would be a trouble for the company as they would have to repay the loans with interest. With stock markets, companies have the free hand to create an initial public offering and raise large amounts of cash without having to worry about repayment. Another reason why the stock market is important is it helps generate personal wealth. For an individual investor, the stock market provides a platform to invest your income and earn a share of the company's profit. Stock markets serve as an indicator of the state of the economy. That is, the stock market serves as a barometer for the economy. A rise or fall in the prices of shares indicates what cycle the economy is in, such as a recession or a boom. The stock market is considered to be one of the most widely used sources for people to invest money in. Investors are always looking to invest in companies with high growth potential. If the stock market is performing well, this increases investment from local investors. It also attracts foreign direct investment as people abroad invest in the local stock exchange. With that, let's now understand stock market prediction. Stock market prediction helps to determine the future value of company stock and other financial instruments traded on an exchange. The whole idea of predicting stock prices is to gain significant profits. Predicting how the stock market will perform is a difficult task to do. There are a lot of other factors involved in the prediction, such as physical and psychological factors, rational and irrational behavior, etc. All these factors combine to make share prices dynamic and volatile. This makes it very difficult to predict stock prices with high accuracy. So we will use machine learning techniques to predict the stock prices of two different companies, Tesla and Google. We'll be using linear regression algorithm and long short-term memory networks for building our prediction models. So first, let's understand the basics of linear regression. Linear regression is a very popular statistical technique used for solving machine learning problems. It is a supervised learning algorithm for predicting the output of a continuous target variable. It can be used to predict the total revenue of a company or the total units expected to be sold of a certain product. It can also be used for weather prediction and stock price prediction. Now here is an example to predict the total number of ice creams a vendor or a company can sell based on the temperature of the day. You can see the green dots represent the actual data points. So the x-axis has the input variable, that is temperature, and the y-axis has the target variable, that is units sold. Linear regression uses the linear equation formula y is equal to mx plus c, where m is the slope of the line, c is the intercept. We find the coefficients and plot the regression line. So in this graph, the red line is our regression line. The best fit line should have the least squared distance between the original data points and the predicted values. Now, let's see how to predict the stock prices of Tesla using the linear regression model. So this is the CSV dataset that we will be using for our prediction. We have information from the 29th of June 2010 till the 15th of May 2019. Here, open column means the price at which a stock started trading when the market opened on a particular day. The close column refers to the price of an individual stock when the stock exchange closed market for the day. It represents the last buy-sell order executed between two traders. The high column is the highest price at which a stock traded during a period. The low is the lowest price of the period. Volume is the total amount of trading activity during a period of time. The adjusted closing price is a calculation adjustment made to the stock's closing price. It is more complex and accurate than the closing price. The adjustment made to the closing price depicts the true price of the stock because the outside factors could have altered the true price. Now before I begin the demo, I want to tell you that if you want to get a copy of the source code files and the datasets that I'll be using in this session, then please put your email IDs in the chat section of the video. Also, please subscribe to our channel and hit the bell icon to stay updated with all the latest trending technologies. So here is my Jupyter notebook where I have implemented my linear regression code. So I'll run through each cell of code and explain what it does. First, we'll import the necessary libraries for building our model. So I'm importing pandas, numpy and matplotlib for numerical computation, data manipulation and data visualization. We'll also import the plotly library for building our graphs. Now, if you are using plotly for the first time, you'll have to install it and then import it onto Jupyter. Let me run this cell. So I have successfully imported all my libraries. Next, I load the Tesla stock price dataset using the pandas library and the read_csv function. I'll also give the location where my CSV dataset is present. Now let me import the dataset. I'll hit Shift Enter. So now I have successfully imported my dataset. Now let's see my data sets. For that, I'll use the head function. I'll write Tesla dot head. So this will return the top 5 rows from the data set. In the next cell, I'm using the info function to find the total rows and columns in my dataset. The info function will also return the data type of the variables and check if there are any null values. There you go. So we have total 7 columns and there are 2193 entries. Here you can see the data type of each column, and each column has non-null values. Moving ahead, in the next step, we are converting the date column into datetime format using pandas library and to_datetime function. Up next, let's do some exploratory data analysis and get more insights from our data. I'm using the print function and a formatted string literal, that is f. These strings contain replacement fields, which are expressions delimited by curly braces. You can see here. Here, I'm finding out the data frame contains stock prices between what dates and the total number of days. So the total number of days can be calculated by subtracting the maximum date value and the minimum date value. So let me go ahead and run it. You can see our stock prices are from 29th of June 2010 till 15th of March 2019, and the total number of days are 3181 days. Now let's see some summary statistics for our data using the describe function. So the describe function gives you the count, mean, standard deviation, the maximum and minimum from each column, the 25th quartile, the 50th quartile, and the 75th quartile. Let me now go ahead and create a box plot to visually check our outliers. I'm considering 5 columns: open, high, low, close, and adjusted close. So this is how our box plot looks like. In this cell, we'll plot a graph using the Plotly library that we have imported. We are setting the layout for our graph using the go layout function. I'm providing a title to the graph. I'm also setting my x-axis for giving the title. So the x-axis will have the date column. You can see it here. We're also defining the title font, the family, size, and color. Similarly, I'm providing the layout for the y-axis. You can see it here. Finally, I'm passing my data list and the layout created to plot variable. Let me go ahead and run it. Now I'll plot my graph using the iplot function. There you go. So we have the stock prices of Tesla plotted in this graph. On x-axis, we have the year from 2011 till 2019, and on the y-axis, you have the price, which is basically the close column. You can see from the graph that initially during 2011 or 2010, the stock prices were growing a little lower than expected, but towards 2015, 16 and 17 onwards, the stock prices grew higher. Now, coming to the most important part, that is to build the linear regression model. So in this cell, I'm importing the necessary libraries and their respective functions. First, I'm importing the train_test_split function from the scikit-learn library. Next, I'm also importing some pre-processing functions like min-max scaler and standard scaler from sklearn library. Also, for evaluating the model and finding the accuracy, we'll use the mean squared error and R squared error from scikit-learn matrix library. Let me run it. So we have successfully imported our required libraries. Moving ahead, in the current step, we are splitting the data into training and testing sets. The x variable contains the independent features and the y variable has the dependent variable or the target variable, that is closed column. I'm taking the test data size as 0.3 or 30% of the total, and I'm assigning a random state of 101. Let's run it. Okay. Now I'll perform feature scaling on the xtrain dataset. For that, I'm using the standard scaler.fit function and passing in my xtrain data. Standardization of a dataset is a common requirement for any machine learning algorithm. They might behave badly if the individual features are not normally distributed. So that's why feature scaling is important. With that, it's time for us to import the linear regression function from the scikit-learn library. Now, using a variable lm, which stands for linear model, I'll declare a linear regression function, and then I'll use the fit method to pass the training datasets, that is xtrain and ytrain. So let me run it. Now we have successfully created our linear regression model. Next, we'll plot the graph for actual and predicted values for the training dataset. Here, we'll be creating a scatter plot and draw our prediction line. So I have used the go.scatter function. I'm using markers for plotting the actual data points, and I have used a line to draw the prediction line. Let me run it. Now to plot the graph, I use the iplot function. If I scroll down, you can see on the x-axis we have the day column or the day variable, and on the y-axis we have the prices of our stocks. The blue dots represent the actual stock values. If I hover over these blue dots, you can see the actual values, and the red line is a predicted regression line. The final step will calculate the scores for evaluating our model. So here we are using two matrices. One is R squared error and mean squared error. For finding the R squared error, we have used R2 underscore score function, and I'm passing my ytrain as well as xtrain using the lmpredict function. Similarly, for finding the R squared error for testing dataset, I'm using ytest and lmpredict for xtest. Likewise, to find the mean squared error value, I've used the ytrain and ytest data along with predicted xtrain and xtest data. Now let me run it. Below you can see the two matrix scores. So our R squared error score is around 0.86 for the training set, and it's around the same value of 0.86 for testing data set, and similarly you can see the mean squared error as well. With that, you saw how to predict the Tesla stock prices using linear regression model in Python. If you want to get a copy of the source code files and the datasets that I'm using in this session, then please put your email IDs in the chat section. We'll share the files over email. Also, please subscribe to our channel and stay updated with all the latest technologies. Now, we will understand about long short-term memory networks. So LSTMs are a type of recurrent neural networks for learning long-term dependencies. It is commonly used for processing and predicting on the basis of time series data. From the image on the left, you can see LSTMs have a chain-like structure. Instead of having a single neural network layer, there are 4 interacting layers communicating with each other in a very special way. Now LSTMs work in a 3-step process. The first step in LSTM is to decide which information to be omitted from the cell in that particular time step. It is decided by the help of a sigmoid function. It looks at the previous state, that is ht-1, and the current input state, that is xt, and computes the function. In the second layer, there are 2 parts. One is the sigmoid function and the other is the tanh function, or the hyperbolic tangent function. In the sigmoid function, it decides which values to let through, that is 0 or 1. The hyperbolic tangent function gives the weightage to the values which are passed, deciding their level of importance from -1 to +1. In the third step, it decides what will be your final output. First, it will run a sigmoid layer which decides which parts of the cell state make it to the output. Then, we put the cell state through the tanh function to push the values to be between -1 and +1 and multiply it by the output of the sigmoid gate. Now let's go to our Jupyter notebook and implement a long short-term memory network to predict the stock prices of Google. Before that, let me first show you the dataset that we will be using. So this is my Jupyter lab, and on the left you can see we have our Google datasets. So we will be using 2 datasets for this demo, a training dataset and a testing dataset. Let me show you how the training dataset looks like. I'll open with CSV table. So this is our training dataset of Google. It has the same columns like date, open, high, low, close, and volume. And if I scroll down, you can see we have data from 2012 till 2016. Let me close this. Now let me open my Google test dataset. So this is my test dataset, and we'll be using this dataset to evaluate our model. So first, let me go ahead and import all the libraries that we'll be needing to build our LSTM model. You can see I'm importing the NumPy, Pandas, and Matplotlib library for numerical computation, data manipulation, and data visualization. We are also importing min-max scalar function from scikit-learn preprocessing library. Then we have some built-in functions from the Keras library, such as sequential to analyze a sequence of data, then dense, LSTM, and dropout to measure the dropout rate. I'll hit Shift Enter to run this cell. You can see it says we are using TensorFlow backend. Now let me go ahead and import the Google training dataset using read_CSV function from Pandas. I have imported my dataset. Now if you want to check the head of the dataset, you can use data.head. Run again. So it will display the top 5 rows from the dataset. Similarly, now let's see the total rows and columns we have in this dataset and the data types of each variable. We'll use the info function for this. You can see this is my output. So we have a total of 6 columns and 1258 entries. And here you can see the data type. So date it has taken as object, open it has taken as float, high it has taken as float. Similarly, close and volume column it has taken as object. Now we will do some pre-processing of data to transform our closing price variable to a numeric type. Drop the non-available data and keep only the close column for training the data. Now to convert the close column into numeric, I have used pd.to_numeric function. Now to drop my missing values, I have used drop any function. And similarly, to consider only closing column as my training data, I'm using iLock or index location. Now let me run it. Now let's once again see the data types. If I scroll down, you can see we have changed the close column data type to float. Earlier it was object, now it's float. Next, we will rescale our data into values between 0 and 1 for better performances. For that, you can use the min-max scalar function and give the range. Then I have used fit_transform method to transform the values. And then I am also printing the shape of my training data. Let me run it. Now we will prepare our data for training. First, we need to prepare our input sequences with 60 time steps of X train data alongside the respective Y train labels. Next, we'll be adding another axis for the batch size, since the input for an LSTM network is a 3D tensor, so it will have a sequence length, the time steps, and batch size. Now, we'll build a model containing 4 layers of LSTM network, all followed by a dropout layer. On the top, we'll also have a final dense layer, which is this one. All of this compiled using an Adam optimizer and a mean squared error as a loss function. Let me run it. Next, I'll train the data using 20 epochs and batch size of 32 using the model.fit function and passing my X-train and Y-train data. This will take some time to run since it will complete 20 iterations. So you can see it has started with first epoch and it will run for 20 epochs. Now we are into our second epoch. You can see the loss that was incurred during the training of the first epoch. Meanwhile, when our model is getting trained, if you have any questions, please put it in the chat section. You can see we have completed our fifth epoch as well. Now we are into our seventh epoch. Now we have entered our 15th epoch. Now we are almost about to finish our training. We have entered into our final epoch now. I think we have successfully completed training our model. Next, let's visualize the loss that was incurred during the training process for each epoch. I'm using the matplotlib library and the plot function. I have given a title to my visualization. I have also defined my X labels and Y labels. So below you can see this is how the graph looks like. On the top you can see the title, that is training model loss. You can see the loss has been a steep decline. With that, let's test the model using a new dataset. We'll continue with the same steps of inputting the dataset. So you can see I'm using the read_csv function to import my test Google dataset. Then we'll convert the close column into a numeric type. I'll then drop the missing values and select the closing price columns for testing. Next, I'm selecting the labels for y-test data. Finally, we are providing the input array for the model and converting the x-test data into a NumPy array and printing its shape. Let me hit Shift Enter to run it. In the next cell, I am predicting the model output using the model.predict function and passing the x-test data. So let me run it. Now if you want to check the values of y prediction, you can just give the variable name and hit Shift Enter. So these are my values. It's not in a proper order or a proper format. Now, to plot the data between actual and predicted stock prices, we'll use the inverse_transform function over ypred data. And finally, we'll plot the graph in order to visualize the actual stock price and the predicted stock price. I'm using the matplotlib library and I'll pass in the data. We're also providing a title to the plot, the X labels and the Y labels. So this is how the graph looks like. On the x-axis you have time and on the y-axis you have the stock price. The red line indicates actual stock price while the green line indicates the predicted stock price. With that, we have successfully created our model and predicted the stock price values using long short-term memory networks. If you have any questions, please put it in the chat section. We'll be happy to help you. Also, if you want to get the source code files and datasets I have used for linear regression and LSTM, then please put your email address in the chat section. We'll send it to you over email.
We have reached the end of this session on machine learning projects with source code. Should you need any assistance, PPT and other resources used in this session, please let us know in the comment section below and our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep running. Stay tuned for more from Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.